back to my channel. Today I'm explaining about the single number. This is one of the easiest problem, and here in the question they are giving a non-empty array of integer nums, and every element appears twice except for one. Find that single one. So what they are trying to explain here, so in they are taking one of the array. So in this array some of the elements are repeating twice except a single one. So we want to find out the unique single one. So that is the first line of statement. And also you must implement a solution with a linear runtime complexity and use only constant extra space. Okay, so here they're given one of the example of 4 1 2 1 2 2 1 2. So here 1 repeating twice, 2 repeating twice, only 4 is the single number of a unique number. So we should the output should be the 4 here, whatever the unique number. So this is the question. I will explain you the problem. Here I'm explaining about the single number problem in a lead code. Let's say we are taking one of the array and with the elements of 4 1 2 1 2. So to solve this problem, there are some of the constraints to solve this problem. What is our first constraint? Our first constraint is we want to find a unique number in this array. That is our first constraint. So our second constraint is we want to find that unique number in a linear runtime complexity and use only the constant extra space. So to solve these two constraints, is there any good approach? Yes, there is one of the best approach. One of the best approach is a binary operation in an XOR calculations. Okay, so there are some of the rules for the XOR calculations. Our first rule is if the two bits are same, then the result is 0. For example, 4 and 4, the both elements are same. We are doing XOR calculation with it and the result is 0. Okay, and the second rule for this is if the two bits are different, then the result is 1. For example, 1 and 0 with an XOR calculation of the two with the XOR calculation of two different elements, then the result is 1. Okay, now I will explain you about the step-by-step process of a binary approach. So in the step 1 here, we are comparing the XOR with 0 and 4. Okay, so if any number XOR with 0 will remain unchanged. Okay, and so this is the 0 binary representation and this is the 4 binary representation. So for calculating this, we are coming from the right side. Okay, so 0 with 0, the both elements are same, so it's 0. In the next here, 0 with 0 and the both elements are same, here 0. In the next there is a 0 with 1. Okay, so there is a difference between the elements, so it's 1. So after calculating all of these with an XOR operation, the result is the result is 4 in the binary operation, because whatever we are comparing with the 0, it's unchanged. In the step 2, we are comparing with the result of a step 1 and the second element here. So 4 and 1, we are calculating the XOR operation. So here the result is 5 in the binary in the binary representation. Okay, in the step 3, we are comparing with the step 2 result and the third element in the array. So after the calculation, the result is 7. So in the fourth step, we are comparing with the result of the step 3 and the next element is 1. So after doing the XOR operation, the result is 6. So 0 1 0 0 is the binary representation of a 6. In the step 5, we are comparing with the step 4 of result 6 and the last element in the array, the 2. After solving that problem, we found out the result of 4. So this is the unique number in the array. So in this way, we can easily find out the unique number. So here we can understand one thing. For this whole process, we are iterating all the elements only one time and we are finding out the result. So that is the reason why the runtime complexity is omega of n and the space complexity is omega of 1, because the result is the element in the array. So pause the video and try in your system how you can able to solve the problem. In session, initially we are taking result equal to 0 and we start iteration in the for loop from I equal to 0 to length of an array, and next we are calculating the values of elements in the array and also the result. Whatever the output of an XOR calculation, it's storing in the result and start doing iteration until the length of an array. So with these, in the end, we can easily find out the result of an element, and we are returning that result here. So it's a very simple program, and so all the test cases were passed, test 2 and test 3 also, case 3 also. So this is one of the best solution here. So pause the video and try in your systems and see.